Hi everyone, let's solve this problem. Longest increasing path in a matrix. Given an m cross n integers matrix, return the length of the longest increasing path in matrix. From each cell, you can either move in 4 directions, left, right, up, down. You may not move diagonally or move outside the boundary. That is, wrap around is not allowed. So, in this case, they have given us a matrix, and also they are saying like longest increasing path. That means all the numbers, let's say if my path is starting here, my next element should be greater than the previous. Again, same thing here, and we cannot go to the next element here because they are of same value. So we should have a increasing value, and we are only allowed to go left, right, up and down. So let's take this example and let's have a DP array as well. Okay, so I'm at this particular cell. Now let's see, from here I can go into 4 directions, right? I cannot go above, I cannot go towards the left, I cannot also go towards the right side because the value is same, and I cannot also go towards the bottom because the value is less than the current value, right? So the maximum, the longest increasing path would be 1, right? Because the value, I can take this particular value as it is, so it is 1. Okay, let me use a different thing. Okay, now let's say I started this particular point. I cannot go to above, I cannot go towards right, bottom or towards left because all these 3 values are less than or equal to 9, and above is not present, it is out of bounds, so the value here is 1. Now let's take 4. So I cannot go above, I can go to the next element here. So if you see here, this side I have one path and I cannot go from here, so it is already computed. So the anything starting with this particular path is already being computed. So what will I do? 1 plus whatever is the result. So we have 2 here, and 1 second, let me remove this path. We have 2 here, and let's say we'll go back again to this particular element. Now in this case, we cannot go towards the left, we cannot go towards the right because it is equal, we cannot go to the bottom because it is less than it, and but we can go towards the up, right? And what is the value inside the cell? Already it is computed, so we can reuse it. So 1 plus 1 is 2, and then we will be at this particular cell. In this particular cell, can I go towards up? Yes. Do I have value? So let's say these are the value. From the above cell I already have a value. Can I go towards the left? Not really, because the value is less than it. So this we cannot take it completely, and towards the right we can go. Okay, we can go towards the right, and this is not computed yet. That means we are going to compute this. So 8 is kind of, again, it cannot go above, below, or towards the right or towards the left because all of them are, so its value is 1. So we store 1, and then when we get 6, what do? We kind of take 1 plus 1, that is 2 here. Now again we'll move back to the cell, this particular cell, and if I am starting at this particular cell, I can move towards, let's say, up. I cannot go towards the right for sure, bottom I cannot even go towards the left side, so I can only go towards the top side. When I go there, I have already computed, the value is already present, so I can reuse it. I don't really have to recompute it, so the value is 3 here. Now again I'll move to the cell, this particular cell. Now we will check the values. So I cannot go towards this, I cannot go towards this, I can go to above. So above value is 2, and also there is a value on towards left value is 3. So let's consider all of this, and maximum of all these values is 3. 3 plus 1 will be 4, right? And then we will move to the last cell. This particular cell, we cannot go towards the left, we cannot go towards the right, we can go towards the top, so, and we cannot also go towards the bottom. So top I will just get, so all other sides the value is just 0, top the value is 1. So maximum of all of these values is 1. 1 plus 1 is 2. So 1 and 8 is the path. So among all of this, the maximum value is 4. So that is what is our answer. So let's write code for this. So initially we will have rows matrix dot length, and we will also have columns matrix of 0 dot length. We will need to write a DFS function to iterate over all the cells. So it will take row, column and previous value. Let's say if row is less than 0, or row is equal to rows, or column is less than 0, or column is equals to cols, or matrix of row comma column value is less than or equal to previous, right? If the value, like let's say for example, if I'm coming from cell 1 to this particular cell, if they are less than or equal, we don't really have to do anything, so we kind of return 0 from this. If okay, and also we have to define our DP array. So array from length initially will be rows, and then I'm going to return new array of length calls, and initially I'll fill all of them with 0 to identify if there is a value or not. Whenever we go to that particular cell, the value will always turn to 1 because at least one cell will be present. So that is the reason. And DP of row comma column, if the value is already there, you just have to return DP of row comma column. Else we have to define directions. The directions are nothing but 1 0 0 1 minus 1 0 0 minus 1. So basically this is to go in the 4 direction, up, down, left and right. So what will I do is I will iterate over direction of directions, and then what will we do, and we also current result will always be 1 because this particular cell, if I am just taking one particular value from that cell also, the result will be 1. So I'll take it initially, and then result is equals to maximum of result comma 1 plus, if I am taking that cell, that is that particular cell, and I'll get DFS of, so in this case direction of, no, basically we have to add along with the row, we have to add direction of 0 comma column plus direction of 1. Then we are going to add matrix value of row comma column for the previous one. So now we will have to store our result into our DP of R and C, and we have to return this particular value. And at the end, what are we going to do? We are going to iterate over every cell. We are going to iterate over every cell using the 2 loops. And now once we iterate, what are we going to do? We are going to, and also we are going to maintain LIP as 0, so longest increasing path, and we, at the end we will return the LIP. So LIP will be max of LIP comma, so LIP comma, we have to call DFS of I comma j with previous value. Previous, initially we are considering the value as minus infinity. Let's run this. Submit it. It works. So basically what we are doing is, for every cell we are going into all directions, and if we have already been to that particular cell, we are storing our answer into dp of that particular cell, and if that particular value is already present, we are not going to recompute any time. So that's the reason at max the entire iteration will be, so for time complexity of this will be big O of m cross n, because at max one particular cell will be traversed once to get the value. Once we get the value, we reuse that value. That is the reason. And the space complexity of this solution is big O of m cross n, because we are using the dp array, which is m cross n. I hope the solution is clear. Thank you.